Good morning and salam sejahtera. So welcome to the to FCAP. Now it's Faculty of Civil Engineering and Urban Environment. Before this is the Faculty of Civil Engineering and Environmental. And first of all, I'd like to welcome to our honourable speaker, Professor Paulus Rahardjo from Universitas Katolik Parahyangan and and also to my mentor, Professor Dr. from UTM, and head of the center, also Professor Dr. Muzila from Smart Driving Research Center, and also from Research Center for Social. And also, I'm very happy because a representative from the other institution from KKTM. Welcome, thanks for the support, and staff and students and others. Actually, Prof. Paulus is not new here. We had a strong collaboration before. We did that with Smile. And then we did a lot of conference and others. And very grateful because Prof. Actually, we hijacked Prof from UTM to come here. But his patience to share the knowledge, since we in a soft soil area. And Prof. Paulus are very expert on the soft soil, especially on testing, field testing. So do get this opportunity to ask a lot of questions, but don't too much because we have limited. Okay, Prof. Paulus actually pursued his graduate study in Highway Engineering Bandung Institute, ITB. Okay, and then master degree and PhD from Engineering Tech, United States America, and very prominent professor Geotech in Indonesia. And then
UTM higher ranking dunia
he was quite dean from and others. And actually, if I read this CV about 3 pages, so I think welcome Prof again. I hope this is not a new or not ending. Please, we need to continue with Katolik Parahyangan, and then we do have a MOU also with the architect, electrical man. And hopefully next we can go to Bandung, very nice place. I like it, the weather and so on. So without further ado, please Prof, thanks a lot, and then give this sharing knowledge.
Thank you for the introduction, Professor Adnan. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Let me speak in English because my bahasa is probably a little bit different than your Malay. Sometimes we are confused because of the difference, but in fact I can understand most of the Malay language. Today I would like to share my experience on the testing of the soft soil and pits, in fact. So main concern is on the testing methods, and also some of the introduction of the formation of soft soil and pit. Let us start with the type of soil. I understand everybody know about soil, and by definition, soil is the product of the weathering of rock. That is the definition. So some people argue if we are talking about pit, is it soil or is it not soil? But let me show you our understanding about soil. We have what we call residual soil. Residual soil is in fact the soil weathered from the rock and then deposited on top of the bedrock. So that is what we call residual soil. And that residual soil usually very strong. So we never talk about residual soil because you can construct even high-rise building on top without pipe. And we can excavate. Last time I excavation 60 meter in the residual soil with very steep slope, one horizontal, 5 vertical. We can do it 60 meter because the soil is very strong. So we are not going to talk about it. But what is interesting is there are zoning. What important in the residual soil is the area of leaching. This is what we call leaching. Leaching means there is some kind of water coming through, and then it washes out the calcium. So this usually become part of the weakness of the residual soil. When the residual soil slide, when there is a landslide, usually it is because of this part. This is the one in Bandung. We have residual soil, and that is the leaching part. Secondly, we have alluvial soil. Alluvial soil is normally because of the erosion, and then it was brought by the river and then deposited along the river. So we call it alluvial soil. But when we are talking about alluvial soil, this is the alluvial soil. It is normally very soft. This is just an example. The SPT is usually 0 to 2 or 3, and then the CPT usually also very small. That is what we call the alluvial. Of course, we have also, that is the alluvial. We have also colluvial. Colluvial soil is different. If the alluvial is being brought by the river, but the colluvial is by gravity only. But both colluvial and alluvial are soft soil. Colluvial and alluvial are soft soil. We have lacustrine, which is in Bandung. In fact, I talked about it in FGTM, but I want to repeat about the lacustrine in Bandung. We call it lake deposit. Lake deposit. This is the geological term for that kind of soft soil. And then we have marine clay or marine soil, where the marine clay is influenced very much by the salt content. Because of the salt content, they usually strong, but once the salt is washed out, the soil changes in the behavior. We are not going to talk about it, but or maybe we will talk about it. And then we have other soil is aeolian soil, which is normally deposited by wind. And we have some of this thing in Yogyakarta. The only place with aeolian soil is in Yogyakarta, in Indonesia. We have organic soil and peats. Usually we say organic soil and peat. It is depending on how much percentage of organic we have. Depending on percentage of organic. And then the last one is what we call volcanic soil. Volcanic soil coming from could be from the eruption. It could be mud eruption. It could be lahar or anything coming out from volcano. I know you are not familiar with volcanic soil, but we have a lot in Indonesia, because out of 500 active volcanoes in the world, Indonesia have 100. A lot of the volcano in Indonesia. Just to give you a look on the organic and peats, and then this is the mud eruption in East Java. Very interesting. We have the sandy tuff, also a volcanic product, and then we have the marine clay. Marine clay is very sensitive. If you do excavation, even though only 3-4 meters, there will be landslide, and that slide will bring all the pile to be tilted. So we got problem. In this special project, I was invited by the owner because about 300 pile collapsed before any erection, of the building. So we need to find how to replace this material, this pile. Let's just mention about soft soil. When we are talking about soil, I would like to mention organic peats. That is most of the time what we mean by organic. The other part is what we call recent sediment. Recent sediment means the sediment sedimented in less than 10,000 years ago. So if it is only 1,000, it is still recent sediment. 2,000, 3,000, 10,000, still recent sediment. Maybe after 20,000, 100,000 million or 1 billion years, that will be something different. We have lake deposit, it is the lacustrine, and we have the mud eruption soil. So this is all what we call the soft soil. Most of the time, people only understand two, organic and peat or recent sediment. But lake deposit is also very soft as well. I believe you know a lot about peat and organic, because I know you have assessed, and that institution is doing very much teaching a lot on this material. But just to give you the idea, usually this is how it looks like. We have two types of the peat. It could be fibrous, we call it fibrous peat, or it could be amorphous, so we cannot see the fiber anymore. Usually it was deposited in a swamp, so it looked like this. This is the one that we obtained from Sumatra. In fact, the biggest pit area in Indonesia is in Sumatra. The area of pit is as much as 5 million hectares in Sumatra, and in Kalimantan we have 3.5 hectares. So a lot of the pits in fact located in Sumatra and Kalimantan. Other areas not much. In Java we have also pit, but very little. This is the how it look like. Usually the pit is located in one of the depression zone where all the vegetation and the rich organic material are deposited together and then become one material. Usually it is not quite homogeneous. In fact, when you take sample from one point to another point, you get a big difference in the properties, because it is not homogeneous. It is unlike residual soil or probably soft soil. Usually it is more homogeneous. So we are dealing with difficult material, talking about pit. The pit, as I mentioned to you, could be fibrous pit or amorphous pit. So the amorphous is more or less very similar to very soft soil. Sometimes we call it ultra soft. So when we say soft soil, the strength is below 25 kPa. We are talking about very soft soil, the strength is below 12.5 kPa. And we are talking about very ultra soft soil, it is below 6 kPa. Usually below 6 kPa, the sample will not stand by itself. So we cannot do the test in the lab. We cannot do test of the ultra soft soil in the lab. We have to do it on site. That is why today I would like to bring to you my experience in the use of the in situ testing. This is how the formation, I think all of you might have understood. There is a depression, usually we have rain, and then all the soil material and the vegetation was formed together into pit. The problem or the engineering properties, as we understand, we have 7 important properties of the pit. First of all, the water content or the moisture content usually very high. It is in the range between 300 to probably 1,500%. One time I have student, maybe 10 years ago, he did investigation on the pit in Sumatra, and he brought to me, the pit. He measured the water content. It was only 200%. So I said, this is not big. Go back to Sumatra and then bring another one with different way. So he did it very carefully, and he come back and he found out the water content was in fact 1,000%, not 200%. So it is interesting. The void ratio is about 20. Void ratio is 20. I did the project in Sumatra for road, and interestingly, if we put embankment 1 meter, the settlement is 1 meter. If we put the embankment 2 meter, the settlement is also 2 meter. We put 4 meter, settlement is 4 meter. Why? Everything is being swallowed by the pit, and even sometime, to your probably surprise, if you put 3 meter or 4 meter, the settlement is 5 meter. And that is true. That is true. Why? Because it is just like water. You put the material on water, it sinks into the water, and even it sinks more than the initial elevation. So dealing with pit is very interesting. But today I'm going to talk more on the properties. Of course, the compressibility is very high. We are talking about compression index in the range of between 2 to probably 10. If we are talking soft soil, your compression index, C sub C, normally between 0.4 to 0.7 or 0.8. That is already high. But in the pit, the compressibility is very high. And then the shear strength is very low, normally between 5 to 20 kPa. In fact, sometimes even less than 5 kPa. there is high degree of spatial variability, as I mentioned to you. You take one in one place and another place, you get different situation, different condition, different properties. Now this is one important thing. When we are dealing with pits, never talk about BVD or vertical drain. Why? Because the pit normally has high permeability. I can show you the test to show that. We are not testing the permeability using the conventional one. Just push the cone and then we know it is high permeability. I'll show you in a while. And then we have the charged and high specific surface area. Usually it is in form of colloidal because the pit is flowing in the water, and there is further potential for further decomposition. So these 7 properties are something that we have to deal with. But first of all, we need to know what is the real engineering properties. We are talking about engineering properties. I'm not going to talk about the chemical properties because it is usually out of range in the civil engineering area. Now this is the basic range of the organic content that we are talking about: soil or peat or organic. When we say about silt or clay and slightly organic, we are talking about the soil having between 2 to 20% of organic content. If we are talking about organic soil, then we have about 25 to 75% of the organic content. And then if we have peat, usually we have more than 75% organic. That is why people will argue whether it is soil or not soil. Now, this is the pit in Sumatra and also in the Malaysian area. I know in the along the east coast of Sumatra, that green, dark green, show the position of the pits. So that is in Sumatra. I know also in Sarawak, pit is located somewhere here. But if you look at Indonesia, those are all pits, a lot wider than in Malaysia. So this altogether is about 5 million hectares of land located on pit. In Kalimantan, we have also, especially in the south of Kalimantan, in Pontianak and also Banjarmasin. This is Banjarmasin. But the amount of the area of the pit is about 3.5 million hectares. It's a lot of pit. Last time, the second President Suharto, has had a project. He called it 1 million hectare of pit. Pit is gambut in bahasa. 1 million hectare of gambut. What he did was he transmigrate all the people from Java, because Java is too many people. It is just small island, but more than half of the Indonesian people stay in Java Island. We want them to go to Kalimantan, because in Kalimantan there are nobody. The land is still far, still wide area. But we send Java people 1,000 people, and people from Kalimantan coming to Java 2,000 people. Why? Because all the job is there in Java Island. So the new president used different policy. Now they put all the money outside Java. Even now our capital will be located somewhere in Kalimantan. So within 5 years, Indonesia will move their capital from Jakarta to Kalimantan. I believe there will be a lot of job. So if you are interested, why don't participate? Yeah, I have to tell you, more than 200 trillion rupiah, 700 trillion rupiah will be put on this area. So Malaysia may be interested, but I know maybe from China, because they have a lot of money, they also want to do the investment. But just let you know, in this area also you will find pits, and also there are a lot of risk, a lot of problem on pit area. Now the problem with pit is because the sampling is difficult. So even if you take the sample, you cannot test the sample very easily in the lab. Especially if you are dealing with fibrous pit, how would you do the test? Because the size of the fibers is too large. Yeah, I just talked with Professor Adnan and Professor Ramli about But sometimes people say the friction angle of pit could be as high as 40 degrees. Is that correct? Because if it is correct, then we can construct embankment with 40 degrees. And I think that is not the correct one. The problem is because of the scale effect. When we are talking about pit, the scale, if you are talking about small scale material, then the major influence is because of the fiber. But if you are talking about huge mass of soil, let's say 20-30 meter embankment or 20 centimeter deep of pits, then the material might not be 40 degrees friction angle. So we have to understand there is a scale effect in the test. So that is why we cannot do the test in the lab. We have to rely the test on site. So it has to be in situ testing. You cannot rely on laboratory testing, except for the physical properties. For the mechanical properties, no, we have to go on site. And then it has very high compression. In that way, if you do the test, you need a certain way of doing interpretation even in the lab. Because majority of the compression is also because of the high secondary settlement. This is very low problem. We have low shear strength. There is also shrinkage problem. That is what happened with my student. He brought the sample from Sumatra back to Bandung, and then he lost 800% of its moisture content. We have stability problem. If you construct something on top of the pit, you have a problem. We do have a very simple way if construction on pit. Usually we construct ditches. We have ditches, and then we dry out the material. Once it dry out, we can step on it. So very important. First time construct a ditch and just let the water down for maybe a few months, 2 to 3 months. From there you can construct much easier. Now what is the problem with the pit? Of course, you know, this is the one in the Pekanbaru area. There are development, housing, and a lot of the infrastructure damage, especially the road damage, and then the boundary wall also damaged. A lot of homes also damaged, and in this area only because of 1 meter fill, the settlement is more than probably 60-70 centimeters. So that is what happened. And again, for the scientific purposes, we don't rely only on the primary consolidation, but mostly because of the secondary compression. And most of the time, if we are dealing with pit, the secondary compression is even higher than the primary compression. If you do the test more than 7 days, you will get also the tertiary compression. In fact, the student that working with me on the pit, he did his consolidation test in 1 year. He forgot that it has been over 1 semester. So he put the pit in the consolidometer for 1 year, and it is still consolidating. Interesting. It is interesting. It doesn't stop. So it is until now. I know there was trail embankment in Malaysia. It was done in 1991. So it was almost 20 years ago. But until now, as I know, it is still consolidating after 21 years, 20 years. So yes, I'm just invited to join the prediction for the future settlement. So it is still there. So it's very interesting. Now, when we are talking about measurement of the mechanical properties of pit, usually we use block sample. The block sample minimum should be 20 by 20 centimeter at least. Bigger, better is bigger. The problem is it depends on what is the size of the fiber. And then we bring the sample to laboratory test. The problem is, as I mentioned to you, we cannot make small sample for say triaxial testing. We cannot, because the scale of the fiber is too much. So what we have to do is we should go to in situ testing. When we go to in situ testing, there are two methods very common. One is the cone penetration testing, usually with pore pressure measurement. Why we need to measure the pore pressure? I will tell you later. This one is good, especially for clay, soft clay, silt, or amorphous pit. But it is not quite good for fibrous pit. If we talk about fibrous pit, we should use the dilatometer. So CPT is very good for very soft soil. I think you should develop this cone penetration testing in Malaysia, especially in this area where you find a lot of soft soil. And then the dilatometer is in fact very new one. This one was developed in the Netherlands in 1930, and then in Belgium about 1936, but was developed in Indonesia in 1950. So the modern CPT was in fact developed in Indonesia in 1952 by a person named Begeman. And Begeman